Good morning, class. So at this point we are doing analytical geometry. You guys had some homework. The homework was exercise 1 on page 192. You had to do numbers 1 and 3. Okay, any problems with number 1? State whether the following equations represent the circle or not. Any problems there? No. You go to number 3. Any issues here? No problems. Not okay, then rather do it. Did you do it? Is that the sum you had a problem? Okay. Any other problems? Okay. This was exercise 1, page 192. Right, let's do this. So in 3.9 we got x squared plus 5x plus y squared is equal to 0. Okay. So we need to get it in the form of x minus a squared plus y minus b squared is equal to r. Okay. So as you can see here, y squared is already a perfect square because there is no y next to it. However, the x is not. So we got x squared plus 5x plus a number to complete the square with plus y squared is equal to 0 plus the number I'm adding. Why am I adding the same number on the right hand side with the equal sign? It's either you minus it, yes, or it's for the equation to balance. Not so. So how do I get this term here? It's b, which is 5 times half. It's 5 over 2, and it must be squared, which is 25 over. So this is what we call a perfect square trinomial. So it will be x plus 5 over 2 squared plus y squared is equal to 25. Any confusion there? Any confusion? No? So what's the center of the circle? It's the additive inverse then, which is negative 5 over 2 and 0. What's the radius? If the radius square is 25 over 4, the radius should be 12. Okay. Any confusion there? No? So now the issues. Alright. So now we're looking at the equations of tangents to a circle. So I asked you to read through this introduction to tangents. No? I've asked you that. Am I right? So at this point you have read that you should have now enough knowledge to determine the equation of a tangent to any circle. A tangent is a straight line. A tangent is perpendicular to the radius. We spoke about that already when it comes to Euclidean geometry. The radius is always perpendicular to the tangent. Okay, so that rule filters in here as well. So we can determine the equation of this tangent. Okay, and in this lesson we will look at how to determine the equation of a tangent to a circle. Okay. So I'm looking at worked example 1 on page 193. Okay. So the question says determine the equation or equations. So it might be one or it could be two. Okay, or more than one. Determine the equation or equations of the tangent or tangents to the circle where x squared plus y squared equals 20 at the point of 2 and minus 4. Determine the equation of the equations of the tangent to circle where in the first case x squared plus y squared equals 20. So if I should draw this, it's a circle. Okay, the radius of the circle is going to be 2 root 5 or the root of 20. But they want the tangent to the circle at 2 and minus 4. So if x is, so that's going to be 2 root 5, because remember this is r squared. So r is going to be 2 root 5. So if this is 2 and minus 4, so that point will lie here approximately. Not so? And the tangent to the circle would be the line going through like that. Okay, and it's going through at that point of 2 and minus 4. Does it make sense? Does it make sense, people? Alright. So the equation of a tangent will be in the form of what? What will be the form of this equation? Y is equal to mx plus c. Not so. Was there a straight line? Not so. So, how do we determine the equation of a straight line? What do we need? We need a gradient and a point of a draw. Or, how else can you determine the equation of a straight line? We have 2 points. Not so? How else? We have an angle and a point. Angle of inclination and a point. Not so? There's 3 ways of determining the equation of the circle. Do we have on this black line, on the tangent, do we have 2 points? No. Do we have an angle of inclination? No. Do we have the gradient? No. But we can actually determine the gradient of that line. Remember, if I draw a line perpendicular or the radius of the circle, the radius of the circle will stand perpendicular or 90 degrees to the tangent. Can I determine the gradient of this tangent? Yes. So work out the gradient of the tangent quickly. Gradient of the radius. Alright, so how do we calculate the gradient? y2 minus y1 over x2 minus x1. The coordinates for the radius is going to be 0 and 0 and 2 and minus 1. So if I make this x1 y1, this of course is x2 y2. Otherwise, if we had made O's coordinate x2 and y2, then the other coordinate is going to be x1 and y1. You can't make one x1 and the corresponding y value y2. It has to be of the same. Okay. So y2 minus y1, so it's going to be negative 4 minus 0 over 2 minus 0. What is negative 4 divided by 2? Negative 2. Okay. So now can I determine the equation of the tangent? And the gradient of the tangent? Yes. We know that the gradient of the radius, which is negative 2, times the gradient of the tangent is equal to negative 1. Why is that the case? Why is the gradient of the radius times the gradient of the tangent equals negative 1? Because the lines are perpendicular. Okay. Yeah, it's from the origin. Hmm? So the gradient of the tangent is equal to negative 1 divided by negative 2, which is? Does that make sense? Do you have a positive gradient for this tangent? Yes. The graph is lying to the left, or the graph is increasing. So it has a positive gradient. Not so? Right. So what's the equation of this tangent now? Y is equal to mx plus c. What is the gradient of this tangent? Half. So y is equal to half x plus c. So how do I calculate c? Substitute the point that this line is going through, which is 2n minus 1. So do the substitution quickly. So x and a y. So I have negative 4 is equal to half times 2 plus c. So what's half times 2? 1. So you got negative 5. So therefore y is equal to half x minus 5. You see it's cutting on the negative part of your x-axis. Makes sense. Right, you guys understand? Is there any confusion? No? Let's look at example 2. Determine the equation of the tangent to the circle x squared minus 5x plus y plus 3 all squared is equal to 1. the y-intercept of the given circle. At the y-intercept of the given circle. So what I want you guys to do is to determine the center of the circle and the radius quickly. Can you do that? Should be able to do that, no? Determine the center of the circle and the radius. We're going to draw the circle, and I'll show you what they are talking about, okay? So determine the center and the radius quickly. Alright, so that's already sorted. However, you got x minus 5x plus a number plus y plus 3 squared equals 1 plus that number. So what's the number in this case? 5 over 2, and must be squared, which is 25 over. This should simply be x minus 5 over 2 squared plus y plus 3 squared is equal to 29 over 4. Okay, so the center of the circle is going to be at 5 over 2, which is 2.5, and negative 3. You all agree with that? It's 5 over 2 and negative 3. The radius of the circle is the square root of 29 over 2. Give me that in decimal form, what would that be? Which means to say, if I go 2,69 up, would it go over the x-axis or not? What is the distance from there to there? 3. Not so. So will that radius of that circle go over that x-axis? No. Okay? So this is what the circle looks like. If this is 2.5, what was that answer? So that's over. So it definitely cuts the y-axis. So that's basically what the circle looks like. Okay. Remember, coming back to the question says the y-intercepts of the given circle. So how do we calculate this y-intercept here? How do you calculate that y-intercepts? Let x equal to 0. So determine those coordinates by letting x equal to 0 quickly. Y-intercept at x equal to 0. Yes? So you got y plus 3 whole squared is equal to 1. If I introduce square root, what must I not forget? Plus 1. So otherwise, you would have written out twice, you've taken the binomial squared, wrote the 1 over and factorized again. Not so. The same thing. Alright? So then we have y plus 3 is equal to plus minus 1. So y is equal to minus 3 plus 1 is minus 2. Y is equal to minus 3 minus 1, which is negative 4. So there is negative 2 and negative 4. You guys understand? Who's confused? What I just did was, I got the center of the circle and the radius to draw the circle actually. Okay? Then what did I do is, I worked out your y-intercepts. Why? Because that is the point of contact. I need to know the point of contact to determine the equation of the tangent. The tangent's equations of course is going to go one through there. And one equation will go through there. The other one will go through like that. Okay? Not so. So let's call this line 1. And this is line 2. So let's go with line 1. Okay. Let's go with line 1. Okay. So what can we, how are we going to solve the equation of this tangent here? We can work out the radius. Let's call that for now radius 1. How are you going to calculate that radius? The gradient of that radius? The gradient of radius 1 is how? How do you calculate that? y2 minus y1 over x2 minus x1. So the center of the circle is 5 over 2 and negative 3. And the other point is what? What's the coordinates of that point? 0 and negative 2. So work out the gradient for me. Then you can work out the gradient of line 1. And then you can determine the equation of line 1. Not so? Not so? Yes, so do that quickly. I'm going to pause the video at this point. Alright, at this point you have indicated you finished. You have completed that equation, so let's do it quickly. So it's going to be negative 3 plus 2 over 5 over 2 minus 0. So that gives us a negative 1 over 5 over 2, which is negative 2 over 5. Is that correct? Alright, so therefore the gradient of tangent 1 is equal to 1 over negative 2 over 5, which is negative 5 over, or positive 5 over 2. Is that correct? Any confusion thus far? No? So what's the equation of line 1? Y is equal to 5 over 2x plus c. So in order to calculate c, I need to substitute a point on this line. Do we have a point on that line? Do we have a point on that line? Yes? Yes? Sorry? 5 over 2. Remember that the gradient of the radius 1, which is this line here, times the gradient of the tangent 1 is equal to negative 1. Why? Because the radius is perpendicular to the tangent. The radius 1 we have worked out to be negative 2 over 5 times the gradient of tangent 1 is equal to negative 1. So to get the gradient of the first tangent on its own is going to be negative 1 divided by negative 2 over 5, which is 5 over 2. You understand? Right. So what point do we substitute? No, the point is lying on this line. 0 and negative 2. So what we have? Negative 2 is equal to 5 over 2 times 0 plus c. So c works out to be what? C is negative 2. Therefore the equation is y is equal to 5 over 2x minus 2. Does it make sense? Right? I'm going to give you now a chance to calculate the equation of L2. Okay? At this point we know that the radius 2 will come from there. You all okay with that, people? You know what to do? You all know what to do? Right, so do that quickly. The sum, if it comes in as from this point, will be worth 4 marks. Determining the equation of a tangent to a circle. In this form it's 4 marks. Okay? 4 marks per tangent. Okay, not 4 marks in total for all this work. Okay. Again, I'm going to pause the video. Okay, I take it you guys are finished. So, let's take this off here. Let's go with radius 2. It's going to be y2 minus y1, so it's negative 3 minus 4 over 5 over 2 minus 0. That's going to give you 2 over 5. Is that correct? The gradient of the tangent 2 is going to be negative 5 over 2. Will you agree with that? You got negative 5 over 2. You got 2 over 5.
Yeah.
Right. So the gradient of the radius times the gradient of the tangent is minus 1. Why? Why is that the case? Because the radius is perpendicular to the tangent. You understand? And if lines are parallel, what do we know? The product of the two gradients is negative. If lines are parallel, what do we know? The gradients are the same of the two lines. Not so. If points are collinear, what do we know? Collinear. They lie on the same line. That means to say that the gradients will be the same. Okay. So that is a rule you need to know. And it comes up often. If lines are perpendicular, the product of the two gradients is minus 1. So if the first gradient is 2 over 5, so the gradient of the tangent times 2 over 5 is negative 1. Divided by 2 over 5 both sides. That cancels. So the gradient of the tangent is equal to negative 5. Okay. So what can we do now? We say that the equation of this tangent will be in the form of y equals mx plus c. Okay, y is equal to mx plus c. We have the gradient? Yes. So y is equal to negative 5 over 2x plus c. So in pursuit of calculating c, what point can I substitute in? It's going to be a point that's lying on the line of L2, which would be 0 and negative. So you got negative 4 equals negative 5 over 2 times 0 plus c, so c works out to be negative 4. So your equation is y is equal to negative 5 over 2x minus 4. Or if you knew that c value is always your y-intercept, then you could have just written negative 4. Okay? And in the previous case, you could have just written negative 2. Okay? But if you didn't know that, you follow, of course, this steps we follow. You all okay with that? What if the question was? Yes?
Why do we use 5 over 2 instead of 5?
Why 5 over 2 instead of 2 over 5? Who can tell her? Negative 5 over 2, is that what you're asking? Who can tell her why we didn't use 2 over 5 for the equation of the tangent? 2 over 5, yes, it represents what? The gradient of the radius. So in other words, that 2 over 5 is this line, the equation of that line, the gradient of that line. Can you see? And we want to calculate the equation of this line, which is the tangent to the circle. You understand? Who asked the question? You. You understand? Alright, then that's why I use negative. Anything else? What if the question was to determine the point where the two tangents intersect? They ask you to work out that point where the two tangents intersect. How are you going to do that? Sorry? Say the two equations equal to each other. You do it by simultaneous equation. Okay? That's the point where the two graphs intersect each other. Right, exercise 2. We are going to do now number 1.1 and 1.3. You guys finished with the first one? Huh? Are you confused? Who's confused what to do? Okay. It's only in the exam that it tells us a different story. No? Okay, I forgot to press record again. Okay, as you can see here, we have calculated the equation of this tangent here. No. I'll be a minute now and be now with him for 1 minute. Okay, so we determined the equation of the tangent center at the origin. And as I indicated here, the equation, since your x values are the same here, it's parallel to your x-axis, which gives you a y value of -1. the y values are the same, it will have an x value, x constant. Okay. For homework, I would like you guys to do exercise 2 on page 196, the remainder of number 1. Then you can do for me number 2 as well. So you do for me number 1 and 2 for tomorrow. People, enjoy the rest of your day. Good afternoon, class.